So, word problems, don't freak out, okay? Not a big deal because we're still going to work with these quadratics the same way we've been earlier in this section. As you see here, we have a little word problem. It says the shape of a bridge support can be modeled by this function. So this is the function we're dealing with. So as far as this word problem goes, we have a function just like we had in some of those other problems. Okay, it's still going to have a vertex. It's still going to have symmetry between the two because we see that it's a quadratic. A lot of the same things are going to be true. X is the horizontal distance in feet from the left end of the bridge to the right end of the bridge. And f of x is the height in feet above the bridge deck. So before we even read the rest of that, I'm going to scroll down here to where our little graph is. I'm going to give you a rough idea of what this is going to look like. So if a bridge, a bridge that kind of just looks like this, that would be the bridge that you would drive your car across. Above that bridge, sometimes you see these support systems that help so that the bridge doesn't cave in or whatever else. It's going to look something like this, okay? It's going to look something like that. You have those, like the wires that come down to help support it, that sort of thing. That's what we're talking about here, okay? So that upside down parabola, which we know it's going to be a frowny face down because of the negative in front of the 1 divided by 600, okay? That's the general shape of what we're going to be dealing with, okay? And then we have some other questions we need to answer as well. So the first thing we're asked to do is to sketch the graph. The second thing we're asked to do, so first we're going to sketch the graph. Second thing, we're supposed to determine the maximum height of that support, so that upside down parabola, what's the very top of that? The maximum means the top of the mountain. So we're talking about the top of that support parabola. And then lastly, we're asked to find the width of that support. So from left to right, how wide is that support? So those are all the things we're going to figure out here. So the first thing we have to do, if we're going to graph a parabola, is we need to look at the vertex. If you recall back from the last section, the last part of this section, I guess, our vertex always comes from this and this. Those are our H and K's, right? That's our H and that's our K. So the vertex for this particular parabola is going to be the point 300. Why did I do 3,000? I'm sorry, let me go back. 300, comma, 150. Okay, that's our H and that's our K. That's to the right 300 and up 150. So let's go down here to our graph. Now this is all you're given on your paper. This is it as far as our graph goes. So let's take a minute and let's put some additional things that are going to be helpful to us on our graph. Let's see here. Okay, so first we want to talk about the fact that, okay, if our parabola is going to be something like that, well then on this side over here we're talking about the height of this support system, and that height is going to be in, if I can write, feet. Okay, so we're going to have a height in feet, and then when we talk about the width of this support system down here, this is going to be our distance. Okay, this is going to be how far from left to right this thing is. That's also going to be in feet. Let's put some additional things on the grid as far as numerical goes. So if 0, 0 is down here, I got 120, I guess this would be 240 here. And as I go across here, I'm going to skip a line and do 240. And why is that there? 360 and 480, 600, and then I guess 720 would be my last label there, okay? So those are going to help us because I just found this vertex, and the vertex is 300, 150. So I need to go to the right 300. So I got 240 and then 360. Right in between that is 300. So 300 is going to be right about there. And then I need to go up 150. Well, 120 to 240. So I guess this would be 240, 60. This would be 180 right here. So halfway between that would be right here. Right about there. That's going to be my maximum. That's the point 300, 150. Okay. So that's going to be my maximum. I know that's going to be the top of my parabola. Now, in order to find some other points, to find the far left point, this is where, you know, the support system has to be attached at the ground, right? It's got to be attached at the ground. So if I take and I put 0 into my function, an x value of 0, that's what this means here. With an x value of 0, if I plug that in up here, I'm going to pause it here. I'm going to grab my calculator. I'm going to calculate this out. I'm going to do 0 minus 300. Then I'm going to square it. Then I'm going to multiply that by the fraction negative 1 over 600. And then I'm going to add that to 150. And I'll tell you right now, the output's going to be 0. Okay? When you put in 0, in this case, you get out 0. So that's going to leave us with the point 0, 0. 0, 0, that's this point right down here. That represents the very left part of our support system. Now, remember, whenever you have a parabola, we know that we have a line of symmetry. And in this case, my line of symmetry is going to be straight down here because I know that that maximum is our vertex. So since the left to go from here to here is 300, if I go another 300 here to here, that's going to give me the other endpoint for this. So I'm going to go down here, and I'm going to put my other endpoint right here at 600. I went from 0 to 300, and then 300 to 600. That gives me perfect symmetry. So since the left end is 300 from the vertex, the right end also has to be 300 from the vertex. And this is the point 600, 0. Sorry, that doesn't look much like a 0. Let me fix that so nobody gets mad at me. Okay, so the point 600, 0 represents that right end. Now we got to find two other points. So we're looking at, you know, I already decided that we're going to plug in 120. So I'm going to go up here to my original, and I'm going to put 120 in place of this x, and I'm going to go ahead and calculate that out. I want you to do that in your calculator. Pause it right now, put 120 in for x, work that out, and when you come back, see if you have the right thing. Now that you're back, you should have gotten 96. So I'm going to graph the point 120 and then up 96. Now this is a bit of an estimation. I know that this is 60 to 120, so a little bit over halfway in between those, right about here, is going to be my point 120 and 96. All right. I know I can use that 96 and I can reflect that as well. So since 120 is the same distance from the axis of symmetry as 480 is, I'm just reflecting this point over to here. So now that I have these 5 points, now it's time to draw the parabola. Okay? Looks like that. That's what our function looks like. So now a couple just quick questions here. The maximum of the function, how high does it go? Well, right here, it goes up to 150. So 150 is the maximum of the function. So the height of the bridge support, which was one of these questions up here, the question said, what's the maximum height of the bridge support? Well, the maximum height is 150 feet. The next question they asked us was, what is the bridge support? So the bridge support width is going to be from left to right. Well, it goes from 0 on the left end up to the right end of 600 feet, so the width of this is 600 feet.